Hi, since last weekend's SBC review was pretty popular, I thought I'd do another one this weekend, but unfortunately I ran out of time. So this weekend I'm doing a mailbag video. Why not? This video is being sponsored by JLC PCB, who make all my PCBs. They can produce 1 to 6 layer boards from 0.4 to 2mm thickness, track widths down to 3.5mm, VO drill size down to 0.2mm, and can handle BGAs, control impedance, cutouts, and really a whole stack of other things. Even better is that for only $2 you can get 10 PCBs in any colour, manufactured in 24 hours. And if you haven't used them before, don't forget to claim your $20 shipping coupon off your first order. Click on the link in the description below to check them out. So here's a package from Crowd Supply. If you don't know who Crowd Supply is, they're starting to become the crowdfunding platform of choice. Kickstarter, Indiegogo, they're actually fine, but with Crowd Supply, however, you have to jump through a fair amount of hoops. They keep a fairly tight control over what projects are actually up on Crowd Supply, so the end result is you get quality products. It's still a crowdfunding platform, but it doesn't have the same ethos as Kickstarter, where you potentially could get nothing at the end of it. So I highly recommend them. If you're someone who is looking at making a maker product, then yeah, go and check them out. Anyway, this is a package that was sent to me by Crowd Supply. So this is a Crowd Supply campaign that's just about to end. They sent this to me last week. I think I didn't get a chance to do a mailbag, unfortunately. So this is called the Matrix LED display, and it comes in two variants, a smaller size and a larger size. So it's of course an ESP8266 driven PCB, and it comes in either 288 or 576 LEDs. So that gives you 32 by 9 or 32 by whatever it is. I don't know. I'm sure you can calculate. They also come in white, blue, red, green, orange and purple. And the LEDs are driven by a matrix display driver. So you can see it's divided up into 4 sort of chunks on this larger board. This is actually a fairly decent matrix display driver. It's PWM controlled, so you can adjust the brightness of the LEDs. And it's got enough RAM on board to be able to store 8 pages. So you can do simple animation without having to load the CPU down at all. So this matrix... Man, I've gone and cut myself. The knife is so dang sharp. Far out. Ah! So this board also contains an MCP 73831 LiPo charger. So you can run this whole thing off a LiPo battery, which is nice. There's an on-off switch, and since we've got an ESP8266, of course you can connect it to the internet. And there's also some Arduino libraries for it as well. And of course there's also STL files for 3D printed cases. So let's fire this up. So I've got a handy LiPo battery here that I normally use for my Pico Projector. Oh, well, that's interesting. Okay, so when I attached the LiPo battery, this semi started to smolder. Interesting. I'm wondering if this LiPo has actually been inverted. Let's chuck it on the microscope and see what's going on. So under the microscope, this is definitely blown, and it looks like the polarity of this LiPo battery connector is actually reversed. So normally the LiPo battery connector looks like this. So you've got a notch on this side, and you've got VCC on this side and ground on that side. So on this board, this has been reverted. So it's around the other way. I might see if I can actually power this board up still. Probably not. What looks like to be a DC buck converter has fried, so I may not be able to deliver the 3.3 volts, but let's see. By the way, here's a handy tip for those people who have lots of cables or lots of power packs. So I got sick of having a drawer full of intertwined cables and power packs. So now what I do is I store all my power packs and all my cables in plastic bags. This way you can never ever get them twisted up, and you can always find the one that you need. So it's quite good. So I wonder if we're going to see any magic smoke again. Oh, nice. Okay, so it looks like the LiPo battery charger is completely fried. That's fine. I can easily replace that and fix it up. So let's see how the other one goes. Nice. That's pretty good. You've got a simple on-off switch. Of course, for these particular boards I'm going to have to change the LiPo battery connector around. So something to bear in mind, this LiPo battery connector is actually inverted. I'm not sure if this is just an issue with this particular board or what. I'll need to check my emails on that. But anyway, let's see how we go programming it up. So let's go into the messy lab area and solder all these connectors up. So I've soldered everything up, and the programmer goes in like this, and you should be able to just chuck that in and reprogram. So one thing to note is that the USB interface over here is used to simply power the board and charge the LiPo battery, and this header over here is used to program. So there's a little bit of soldering that's required. So let's get into it.
A milliweek later.
So it's a bit sad really, I wasn't able to get either of these modules working. One of the programmers is Cactus. I'm not sure what's going on there. They just sent an email off to find out why I couldn't actually program them up. So this uses the CP2102 UART to USB bridge, and a common issue with those is that you need to have a powered USB hub. Standard USBs on PCs don't support enough juice to these things. But of course I tried to put it onto a USB hub, but I couldn't get it going, which is a bit of a shame. So I know that they can actually be programmed. I just wasn't able to do it with anything Linux, Windows and Mac, and that's a bit of a shame really, because they look really cool. Another one, look at that. So this is a Pico DLP projector, which is very similar to the DLP 2000 EVM module that I'm basing my Pi projector on. It's got a manual focus control, it's got an SD card for playing videos, a USB charging LiPo, so it's very identical to my Pi projector. The only disadvantage with this one is that you can't get access to programming this thing. All you've got is pure basic playback of video, and it's got a little inbuilt fan in it, so it keeps things cool, because even though this is a plain LED projector, it still does get quite hot. Let me just turn these studio lights off, and this is pretty much the display that you get. And let me see if I can control this. Okay, I've preloaded this video up. It's playing back pretty well. You can see the audio is sort of skipping out of time to the video, so it's not really keeping up with the video. But apart from that, it's completely identical to my Pi projector. So I think I need to crack this open, because you can pick this thing currently up for $99 US. So 950 milliamp hour battery, it's fairly decent, and we've got all the classic DLP 2000 chips. It's a DLP 2687, which is exactly the same as the one in the Pi projector, and looks like it's using some sort of custom jobby. e-tron Tech U44CH078, but let me just check out the datasheet. So let's see what's on this side. There's got to be something else underneath here. Oh yes, and this is fantastic. So this is an F1C100A. So this is an all-winner chip that specializes in sort of run-of-the-mill 1080p video decoding, and this is absolutely fantastic because it's a package that I can easily hack into, and if I poke around a little bit I might even be able to find some sort of UARTs there, and I should be able to reprogram or reflash the firmware in this. So this would be the probably SPI flash, which holds the firmware. Absolutely, completely hackable. So that's nice. So I just noticed that both the data lines on the USB are actually connected up. So I'd say that this is probably acting as some sort of storage device if you connect it up to a PC, possibly. But we might be able to get some other action out of it. Let me just try that. Okay, so I just tried to plug it into a Linux box and no response at all. So it's not acting as a storage device. So that's the thing about these particular products. There's a lot of mechanics involved in this. So it's quite difficult to produce this sort of thing. In terms of my Pi Projector, it doesn't really affect my Pi Projector at all. That has a different market. I'm aiming for a maker type market where people just want to hack around with projecting whatever they want from a Pi. It's quite interesting to crack this open, but I absolutely do need to hack this all-winner sock and see if I can change the firmware and get it to do something a little bit more reasonable. So another thing I could actually do is make another PCB that sits in here and provides HDMI out, which is something I was intending to do with the Pi Projector. So here's another one. I have no idea where this came from. Oh, excellent. So the Banana Pi guys contacted me a while ago, I think, and they thought they would send me a couple of boards to check out. So this is the Banana Pi 2.0. So they've given me a power over Ethernet connector, which is something I wanted to check out. And this is the little baby. Nice. So this board runs the quad-core Cortex A7 all-winner H2 Plus, which we've seen on several other SBCs. 512 meg RAM, 8 gig eMMC, 100 megabit Ethernet, which also supports PoE, Wi-Fi, Bluetooth, HDMI, and also a 40-pin GPIO header. Nice. That's the Banana Pi 2.0, and this is the Banana Pi M2M, which is something that came out a while ago, but I just haven't had a chance to review it yet. So the Banana Pi M2M is a fairly decent little board. It runs the quad-core Cortex A7 all-winner A33, has 512 meg DDR3 RAM, SD slot, 8 gig eMMC with an optional 1632 or 64 gigs if you want, Wi-Fi, Bluetooth, MIPI CSI and DSI, mic, USB ports, and a 40-pin GPIO header. Nice. I can't wait to get into that one too. So I plan to review these two boards soon. I've actually got a bit of a backlog of SBCs to review, which is a bit of a pest. So I might do sort of some mini reviews on these two, as well as NanoPi Duo 2, NanoPi M4, got a Cadus Vim 2, another Orange Pi board. So there's actually a whole stack of SBCs I've still got to review. Stay tuned for those reviews coming up. Excellent. So I've been pretty busy the last couple of weeks concentrating on my wyrks-UPS board. So for those people who don't know, I'm providing a simple PCB that provides UPS capabilities for embedded devices. So I can support a Pi 0W. It may be able to support a Pi 2 or a Pi 3, but it's specifically designed for Pi 0W down. The whole goal is to be able to get this PCB down to around 20 microamps in sleep mode. So it's got a full RTC on it, so it can wake up the main CPU on demand. LiPo charging, DC boost converter. It runs off 5 volts, and there's also going to be a companion PCB that will expand the DC input voltage from 5 volts all the way up to 30 volts or something like that. So, so that's the goal. So I've been trying to look at optimizing power consumption, and I'm also using the ATtiny 416, which is so new it doesn't even have any core Arduino libraries for it, so I've had to write everything from scratch. So I've gone through all the I2C bus specification, and I've written a fully fledged library to be able to support the ATtiny 416. So I'll put that up on GitHub just as a standalone library for anyone who's interested. So as you can see, the current consumption is around about 3 milliamps when the CPU is in 20 megahertz mode. So 20 megahertz is only required for I2C communication, and I've discovered that if I go down to a 32 kilohertz clock, the I2C communication of course isn't fast enough, and there's a lot of devices that just won't be able to cope. We're talking about an I2C speed of around about 8 kilohertz, which is next to nothing. So the AT-Tiny can dynamically switch clock speeds, similar to a SOC on an SBC being able to change its clocking frequency. So I can go down to 32 kilohertz, which is really ultra low power, and at that sort of frequency I should be able to get down to 20 microamps, maybe even lower, but my goal is 20 microamps. So while I was writing the I2C library, I discovered a few quirks with the silicon. This is a common thing that happens with semiconductor manufacturers, so hardware mistakes are a lot harder to fix. However, there's one particular I2C bug which sort of pushes it into a bus error mode if the timing isn't right. So I've had to force the bus to go to idle mode. So this particular flag here tends to get set when the AT-Tiny sees some sort of weird error on the bus. So as you can see, it's actually behaving quite normally, but hey, for some reason it's just throwing a bus error. Maybe it's some sort of very small timing issue between when it expects the bus to get to a certain state. I don't know, but anyway. So that's something I found out with the AT-Tiny 416. It's got a bit of a dodgy stop condition on the I2C implementation. So I'm pretty close to completing the basic software for the WorksUPS, and once I've completed that, I'll get on to the Pico Projector, and then also I'll be able to launch my crowd supply campaign, which would be nice. It's a long time coming, I know. There's also some other boards planned to manufacture as well, which is a Pi logic level converter. There's also an OBD board, there's also GPS board, and a whole series of other boards. So I also might even chuck in an ESP8266 board as well. You'll be able to mix and match any type of PCB you want. If you want to add in GPS functionality, you know, WS2812 control, you can just sort of daisy chain these PCBs on and have them work. So one other thing before I go, around about this time last year I was looking at rebuilding my studio because I was running out of storage space in the old studio. So I expanded out into this large sort of TV room and made it a lab/studio, but I still had issues with storage, and as you can see I don't have a heck of a lot of space to be able to store stuff. Really, stuff is just kept under the desk, which isn't really that good. And one of the big issues with storing a whole lot of little electronic components is storage. You can never really find the right box that you want, and it never really fits in the cupboard that you want, and it's just a bit of a nightmare. However, in Australia there's a hardware store called Bunnings, and they sell these boxes called Tactics boxes, and they are just a perfect size for storing electronic components, and you can have these little trays that pull out and go back in again. But I've been trying to find something that can actually fit all those Tactics boxes in. And so a mate of mine, Keen Maisels, who runs Keen Electronics up at Mount Kringai, put me onto this particular thing, which is absolutely fabulous. So this is actually what's called a gastronorm trolley, and it's used in the food industry. You would have seen it in cafeterias where they pick up the cafeteria trays and slide them into these little slots. But I found it actually perfectly fits these Tactics boxes. When I say perfectly, there's a little bit of a tight fit in some places, so I might have to chuck in a little washer to push the sides out a little bit. But the big advantage is that I can stack them from both sides. It's on wheels, and that's one of the big requirements of the studio, is that everything in the studio has to be on wheels. So if I wanted to be able to shoot in one area or the other area, I don't have to physically move stuff that's bolted down or not on wheels. So this is probably the best sort of storage mechanism I've come across, which is unusual. So my last video gained me around about 3,000 extra subs. So I reckon I need to run another competition. So stay tuned next week for that competition. Thanks for watching. See you next week.